Here's how we can get a design matrix out of the GLM procedure. So suppose we have this data set, and I just made it up here. This is just an invention. I'll go ahead and show you the plot so you can kind of see what's going on. I basically have analysis of covariance. I have one continuous variable, this x variable, and one categorical variable. The categories are A, B, and C. As you can see, they form three very distinct lines, so we should get small p-values for the slopes and the intercepts. So basically what I want is I want this thing to give me the design matrix for this model. This is the model that I'm worried about. And I just use this. This should be a SAS keyword. It should turn blue. I'm just going to use this outDesign equals matrix. This is going to be, matrix is the name of the data set. And this data set is really just the design matrix. So I'm going to use it over here. I'm going to print it out for you so you can see what's going on. And note that this matrix is a little over-parameterized. So here's the matrix. And it just gives you, Y is still called Y, but everything else is called column 1 through column 8. This first column is just the one vector, that's the intercept, if you will. This is just that X vector, the covariate. And then this first set of three variables is indicator variables. And remember that we have three groups, so I have three indicator variables. So column 3 plus column 4 plus column 5 will actually give us column 1. So you don't want to use all four of those variables in any model. And then this is the indicator variables times X. So column 7, for example, is column 4 times column 2. So if I scroll on down, watch column 7, and it turns into zeros at the same time that column 4 does. So you can keep on going, and then eventually you get column 8 and column 5 to be something. Okay, so that's the idea. Now, of course, you're never going to use all of those variables in the same model, but they're there for comparison. Now, what you would usually do if you want to fit three slopes and three intercepts in a model together is you would use this proc GLM. You'd put the categorical variable in there and then X times the categorical variable, and that'll give you estimates for the three separate lines. I'm going ahead and putting a no